Okay, we're on the endless march towards the end, but we're certainly at the beginning of our journey. We're at exercise 6. And exercise 6 is, material you have to get through first before you can even think about doing exercise 6. The material that you're going to be doing is, certainly as every section we've done before, there's content. You want to look at that. You want to look at the examples. That's something I'm going to be working on over here. And then you get busy with the exercise. But the deal of my belief anyway, if you understand the content and the examples, the exercises just fall into place, and your skill set will improve over time. All right. So what I'm going to do, I'm going to kind of scroll through this, and it says special methods of multiplication. I'm not too worried about what he considers to be special, but I'll go through it. I mean, certainly I'm going to go through it. He talked about special patterns like squaring a binomial. And I'm not too worried about it. I'm just going to say I read through that. He talks about, all kinds of things. And you may not realize there's a lot of things to look for, a lot of patterns and stuff. And again, I'm not claiming it's easy to look through all those patterns. But the bottom line is you're going to reinforce things by doing things. All right? Yes, I'm scrolling through this. Talks about cubing things. Right? Kind of complicated, no doubt about it. I'm not saying it's not. But my claim over here is I wouldn't worry so much about it. I'd worry about getting busy. So when I look at these things over here, I do point out he is big on patterns. There's no doubt about it. So some of the patterns he talks about if you square a difference. Now, I believe if you did that, you'd have a minus b. And if you did the multiplication, you get a squared minus ab. Now, some people say minus BA, but I'm going to put down minus AB plus B squared. So this thing turns out to be pretty simple. It turns out to be A squared minus 2AB plus B squared. All right? Now, I'm going to say that's a nice pattern to know, but when you're first doing problems, I don't think it's an important pattern to know. So what do they want me to do? They want me to square this thing. I'll write this down for you. Well, someone says, we just did that. Could we just write that down with doing no work? Well, this is where Wells says you should write down doing no work. In other words, you should take the first term and square it. I'll write that down for you. That would be 9a4. Then he says the middle guy is minus 2 times the product of those two things. Well, let me write that down. Was that going to be minus? Well, you'd get 12. And then you get a squared b. Then his last term squared, which would be plus 4b squared. Now, that's Wells for you. He says, oh, that's what you should be doing. What I'm going to think is you really shouldn't be doing that. What you should be doing is thinking about it. That's what it means. And then do it. What's 3a squared times 3a squared? 9a4. Then you get 3a squared times minus 2b. That's minus 6. A squared b. Next term is going to be minus 2 times 3a squared. That's minus 6 a squared b. You notice I like to write the factors in alphabetical order. And last but not least, you get the minus 2b times minus 2b, which is plus 4b squared. So I'm not really doing patterns. I'm just doing the multiplication. What do you get? 9a4 minus 12a squared b plus 4b squared. Same thing I did before, looking at a pattern. I wasn't looking at a pattern, I was just multiplying it. By multiplying, you'll start to learn patterns. Are we getting the same answer they told us to get? We sure are. 9a4 minus 12a squared b plus 4b squared. All right, let's put this one down. And again, as I write things down, you may say, I like to write them differently, and I'm not opposed to that. So it's going to be minus 4 x cubed plus 9. Well, if I'm doing what Wells said to do is just, follow the pattern, square the first term, which would be 16x6, square the last term, which is going to be plus 81, and then the middle term is going to be minus twice the AB, right? What do you get over there? 18 times 4, 40 and 30, 72. I got to be honest with you, if you're not thinking though, it's going to be it's a terrible thing to do if you're not thinking. I'll claim that's an answer using Wells's technique. But what I want to do is I want to try to do it a little differently. I'm going to write it down as 9 minus 4x cubed times 9 minus 4x cubed. I'm going to just do multiplication. Now someone says, why'd you write it that way? It's just easier for me to write it that way. 9 times 9 is 81. Then you get minus 36, x cubed, minus 36, x cubed. I'm just multiplying, by the way. And plus 16, x6. Does it simplify? Sure does. 81 minus 72, x cubed, plus 16, x6. Are we getting this? Let's take a look. 81 minus 72x cubed plus 16x6. By the way, this is the same thing. There's no difference between any of them, all right? Some people say, I don't like your order. Order really doesn't much matter at this level. All right, let's do this one over here. This is also a special pattern. And again, we hope by trying that you know there's special patterns in the text. And write this down. They want to multiply 6a plus 5b cubed, 6a minus 5b cubed. Well, again, Wells is of the opinion that this should be done by inspection. And really, what is he noticing about this is a pattern. And he's really noticing this pattern over here. And he says, oh, that's easy then. What do you get? 36a squared minus 25b6. But by the way, I'm not saying everyone sees that. But Wells says, oh, you do it by inspection. I'm actually going to do the work. So I'm going to write down what the work is going to be. 6a plus 5b cubed, 6a minus 5b cubed. Let's multiply it out. What do you get? 36a squared minus 30ab cubed plus 30ab cubed. I'm just distributing those two terms, 6a and 5b cubed, across the term 6a minus 5b. Then what do you get? Minus 25b6. What's nice about this? Middle term disappears. We're getting the same answer. Question is the same answer over here. It is. This is what's known as a difference of perfect squares. All right, let's do the next one. And again, as I do these things, I'm not saying you should do what Wells says, like by inspection, by inspection, by inspection. Let's do it. Let's do this right over here. Minus x squared plus 4 times minus x squared minus 4. I'm going to multiply. Minus x squared times minus x squared is x4. Then you're going to get plus 4x squared minus 4x squared minus 16. What does this give me? x4 minus 16. I'll look at the key later. But I do want to point out, you know, one thing you may want to try to do is just what Wells is saying. And I'm saying this really does look like A plus B, A minus B. With the understanding the A in the problem is minus x squared, and the B in the problem is going to be 4. So if you were to write this down, what would you get? You would get A squared minus b squared. What's a squared? Well, if you square a, you get x4. And if you square the 4, you get 16. Do we get the same result? Of course we do. My goal, though, is to teach you that it can't hurt to try. Like, if you're looking for patterns at this level, yeah, you should, but you shouldn't start with a pattern. You should start with multiplying and then say, oh, yeah, there's a pattern there. All right, let's keep going. Now, granted, these are more complicated. They are doable, though. I'm going to multiply. It says expand. I'm going to distribute the a across those three terms. You would get a squared minus ab plus ac. Now I'm going to distribute the b across those two terms. What would you get? Plus ab. And then what do you get? Minus b squared. I'll write that over here. And then what do you get? You get plus bc. Now let's do the c. What are you going to get? You're going to get minus ac. And then what are you going to get? You're going to get plus BC. Then what are you going to get? Well, minus C times C is minus C squared. So I'll draw my little line over here. I'm going to say equal now. What is it equal to? A squared minus B squared minus C squared. These disappear. These disappear. And what's BC plus BC? 2BC. We're done. Let's do the next one. Now again, we're going to multiply. We're multiplying. X times x is x squared minus xy. We're distributing x across the three terms, x minus y plus c. Then we get xc. Now I'm going to distribute the y across those three terms. What do you get? xy. You get minus y squared plus yz. Let's keep going. We're going to distribute z across now. What do you get? xz minus yz minus z squared. I'm sorry, plus z squared. Sorry about that. Put a little line over here. I'm going to add that stuff together. What do you get? X squared minus y squared plus z squared. This disappears. This disappears. And we get 2xa. Look at the k. Make sure you can agree with that. What are we seeing? X squared minus y squared plus z squared plus 2xa. All right? 7's far easier. I'm kind of wondering why they even put it there. Well, let's go through that. They want to multiply it. Right? What's nice about multiplication, the order in which you put it down really doesn't much matter. What do you get over there? And again, Wells' opinion, you should just write the answer down. I think you should too at some point. So x squared plus 3x minus 5x minus 15. What would you get over there? X squared minus 2x minus 15. That's done. So the next one, not bad. AB minus 4 times AB plus 7. And again, Wells' of the opinion you should do this without too much work. And I kind of agree with it, by the way. I think these really don't require much work. But you're not at that stage yet. At least I don't think so. If you're watching videos, you're probably not at that stage yet. So what does this give me? A squared b squared plus 7ab minus 4ab minus 28. Well, those two terms are like each other. They both have the same variable part, and you would get 3 of those things. Let's just put a box on it. I want you to look at the k and make sure you can agree with that. Working like a charm. All right, let's look at number 9. And again, I know you might look at these things, you're doing a lot of tricks over here. Maybe, right? And Wells is big in that trick too. But I just trying to get across to you, you really need to multiply. All right? You'll see patterns over time if you just simply try to do the multiplication. M times m is m squared plus mn plus 8m. I distribute the m across those three terms, m plus 8. Now I'm going to distribute the n across those three terms. What do you get? mn, n squared, 8n. Now I can do the 6. What do you get? 6m, 6n, and 6 times 8 is 48. Put a little line. I'm going to add them together. That's what you get. M squared plus n squared plus 2mn plus 14m plus 14n plus 48. Whoops. Let's see if we got the right answer. Well, I'm seeing the m squared. I'm seeing plus 2mn. I'm seeing n squared. I'm seeing plus 14n. Yeah, 48. Got everything right. All right. let's do the next one. Again, I know it's difficult, but, try. And again, I do write the patterns down for you, but I could, if you see it, you see it. You don't see it, just do the work. That's what squaring means, by the way. 2x squared times 2x squared is 4x4. 2x squared times minus 3x is minus 6x cubed. 2x squared times minus 5 is minus 10x squared. Now let's do the minus 3x across those three terms. What do you get? Minus 6x cubed. Then what do you get? 9x squared. Then what do you get? Well, it looks like you get plus 15x, right? Now we're going to do the minus 5. What are you going to get? Minus 5 times 2 is minus 10x squared. And minus 5 times minus 3x is plus 15x. And minus 5 times minus 5 is going to be plus 25. Add them together. I'll write it down for you. You get 4x4 minus 6x cubed minus 6x cubed minus 12x cubed minus 10 plus 9 minus 10 is minus 11x squared. And 15 plus 15 is 30, and they're x's, and then 25. I'm going to commit it to as an answer and check it. 4x4 minus 12x cubed minus 11x squared plus 30x plus 25. All right, a little more complicated. All right, a little more complicated. And this is find the cube. And certainly my goal over here is, I think a pattern might be appropriate. All right, and they give the pattern over here. And this is a pattern that really kind of emerges into a very simplistic pattern, and that can be proved. All right, I think it's an important pattern to know, by the way. What are you going to do? Well, I'm going to write this down in order. It's going to be a cubed. Then there'll be plus another term. That term will have an a squared in it. Then there'll be another term, 11a in it. And then there'll be another term with no a in it. So 0 a's, when I say 0, 0 factors of a, 1 factor of a, 2 factors, 3 factors of a. And then I do the same thing for the 2b. And what's that going to be? Well, it's going to be 2b cubed, 2b squared, 2b to the first power, and then no 2b's in that first term. Then there's coefficients. So I'm not saying everyone has this down yet. Well, the coefficients are going to be these. So there's going to be a 1 here. We'll clean it up later. There's going to be a 3 here. There's going to be a 3 here. And there's going to be a 1 over here. Let's just clean it up. What do you get? A cubed. And that's going to be 3 times 2, which is 6. A squared b plus, well, 2 squared is 4, and 4 times 3 is 12. A b squared. And what do you get in the end? Well, 2 cubed is 8, b cubed. Now, if you're looking at it and say, I couldn't have done that, all I can say to do that is this. A plus 2b, A plus 2b, A plus 2b. All right, if you were to multiply that out 2 at a time, A squared plus 4ab plus 4b squared, a plus 2b. Continue to multiply. Let me do that for you. What do you get? Oops, sorry about that. You're going to get, let's see, a cubed plus 4a squared b plus 4ab squared. Now distribute the 2b across it. What do you get? You would get 2a squared b. Then you would get plus 8ab squared plus 8, sorry about that, b cubed. If you combine all that stuff together, I'll put it over here, you would get a cubed plus 6a squared b plus 12ab squared plus 8b cubed. Look at the answer key, you get the 8b cubed, 6a squared b, 12ab squared, and 8b cubed. All right? I want to point out me looking at the pattern, really the same thing, no different at all. All right? That my answer by doing long multiplication or looking at patterns is no different at all. All right? So let's look at number 12. And I mentioned I really do enjoy doing the pattern on this one. It's a lot easier for me. And I'll write it down for you. All right? So we're going to cube this guy. And so what are you going to cube? I'm going to erase her out. A little aggressive there with that. And I'll write this down. I'm going to cube this. I'm going to start writing it down. 2x cubed plus, well, I know the pattern in this. Remember what I did before? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. It's this row. So 1, next one's going to be 3. 2x cubed squared. And then there's going to be one factor of 5. Oh, you know what? I made a mistake. The factor is going to be, I'm sorry about that. This is going to be written as 2x cubed plus minus 5y squared cubed. All right, I'll write that down. It's minus 5y squared, one factor. What's next going to be? Plus 3 2x cubed minus 5y squared squared. Last but not least, plus, that's going to be 1. I'm not going to write that down. But what are you going to get? Minus 5y squared cubed. Let's do one term at a time. That's going to be, 2 cubed is 8. X cubed cubed is going to be 9. This is going to be minus now. And I'm looking at that, and let's take a look. I got, let's see, 4 times 3 is 12. I'm just doing the number first. And 12 minus 5 is going to be minus 60. X6, y squared. Let's go to the next one. It's going to be a positive term now. How do I know that? I'm squaring minus 5, which is 25. 25 times 2 is 50, and 3 times 50 is 150. We'll look at the key later. X cubed, and y squared squared is y4. Last but not least, what do you get? Minus, well, the reason I minus because minus 5 cubed is a negative number, so 125. That's what 5 cubed is, by the way. Y6. Look at the key. I'm just looking term by term. Yeah, we did it right. The next one. Oh, they say it's a nightmare too. Someone says, where do you see it says it's a nightmare? Right over here. Very tedious. So what I want to do is encourage you, even though it's tedious, I still think you can do it. I still think you can do it. All right? So when I do it, I got to be honest with you, there's a variety of ways of doing it. I don't think there's only one way to do something. But what I prefer to do, and by preferring, I'm just going to multiply. Right? Like the thuggish thing you could do is just multiply. I'll write that down for you. Whoops. And realize for some students, this is just crazy difficult. One thing nice about an answer key, you can look at your answer key and see if you got it right. So I'll tell you what I'm going to do over here. I want to do these two first. And I'm going to be very careful about it. That would be 4. x6 minus 2x5 plus 4x4 minus 6x cubed. That's done. When I say it's done, the distribution of 2x cubed. Now I'm going to distribute x squared across those terms. What would I get? Minus 2x5. Then what do I get? I would get plus x4. You notice that things line up pretty nicely. Then what do I get? I get minus 2x cubed. Then what do I get? I get plus 3x squared. So I did this, now I do the 2x. What are you going to get? 4x4. Yeah, I noticed a lot of work. Then what do you get? Minus 2x cubed. Then what do you get? You get 4x squared. You notice I put columns in, right? Then what do you get? Minus 6x. This is done. Now what are we going to do? I'll do minus 3. So it's going to be minus 6x cubed. Then you're going to get plus 3x squared. Then what are you going to get? You get minus 6x, right? And then you get plus 9. Now, I know it's tough. It's this whole thing times this. Before I do that, I'm going to simplify. And what do you get? Well, I'm going to write a little differently. I'm going to write it as 2x cubed minus x squared plus 2x minus 3 times 4x6 minus 4x5 plus 9x4. Let's see what you get there. Let's see, minus 6 minus 12, and then you get minus 16. Then you're going to get 3 and 3 is 6 plus 10, right? Minus 12x plus 9. It's tough. There's no doubt about it. Let's keep going. Well, I'm going to distribute the 2x cubed across those terms. What do you get? Let's take a look. 8x9 minus 8x8 plus 18x7 minus 32x6 plus 20x squared. I'm sorry, x5. I misspoke. Minus 24x4. It's a lot of work. And then what do you get? Plus 18x cubed. This is done. Let me do the x squared now. What do you get? Minus 4x8. Then what do you get? Plus 4x7. Minus 9x6 plus 16x5 minus 10x4 plus 12x cubed. And then what are you going to get? Minus 9x squared. This one's done. Let's do the 2x now. Well, you're going to get 8x7. Minus 8x6. And then what are you going to get? 2 times 9 is 18. X5. Let's keep moving. Minus 32. X4. Plus 20. X cubed. Minus 24. X squared. And then what do you get? 18. X. We're almost over, by the way. Minus 12, x6. Plus 12, right? Plus 12, x5. Minus 27, x4. Plus 48, x cubed. Plus 36, x. Ooh, I forgot somebody. Let me get back there. I'm sorry. I'm daydreaming again. It happens to me sometimes. I just daydream and I can't remember when I'm doing things. So how do you know? I'm not seeing a pattern. So minus 27, x4. Let me just make sure I got that right. Minus 27, plus 48, and then it's minus 30. I'm sorry. And then plus 36. And last but not least, we have something there, right? That's minus 27. I hate these, I'll be honest with you. They're really, part of that's just the act of getting it. And then you wonder, did I get it right? Well, let's write this down. Just adding things together, by the way. Let's see, what do you get there? 2230, right? You might be surprised that you'll make a mistake somewhere. And you'll know this by looking at the key. And some of the mistakes are just silly mistakes, but I don't want to make a silly mistake. So let's see, minus 20, minus 52, minus 61. Now, if I make a mistake, I will look at my work. And this is going to be what? I'm seeing 20, 30, 50, 66. Let's see what I get here. 24, 34, 36, 66, 76, 86, 86, 93. Let's see, 30, 40, 50, 98. And then what do you get? Minus 30, 54, 63. Let's see, 36, 46, 54. Minus 27. So I'm just going to look back over, and I know it's tough. And I'm just kind of looking at one thing at a time. And I'm hoping. After all work, it's just awful to make mistakes. And you have to back over it, and you get frustrated. Take a break. Bingo. Got it right. Okay. I know it's tough. And that was a tough one. No doubt about it. All right? Now, if you notice here, I do little patterns for you. But, do what you need to do. All right? So then there's exercises. And my recommendation to you is do the exercises. Make sure you can do it. So get through all those exercises. There's a lot. There's a lot of work over here. And you might say, I'm getting dizzy or tired doing that stuff. Yeah, it's tough. I'm not saying it's easy. It's hard work. There's a lot of lifting involved there. But all that exercise does pay off. All right? And so when this problem's in, there's 45, 46. Oh, 46 problems. Then what do you get to? You get to the SAGE business. Again, it's a computer algebra system. We're recommending you take a look at it. Again, a CAS system. Go to the website. You can either download it or use an interactive web application, which is fine. That's presently called CoCalc. And you may want to try these commands to see what it's like. All right, try it. Now, again, if you need to reach out to me, I'll write my email address down again for you. Bannon, that's B as in boy, ANNON.US. And that's it. End of story. Thank you.